Welcome to the series of e-learning modules on measurement of mortality crude, specific and standardized death rates, infant mortality rate. By the end of this session, you will be able to explain the measurement of mortality such as crude death rate, specific death rate, standardized death rate, infant mortality rate. Let us start with an introduction. The word mortality came from the Latin word morus, that means death. Mortality rate is the death rate. Mortality rate is a measure of the number of deaths in general or due to a specific cause in a population, scaled to the size of that population per unit of time. Mortality rate is typically expressed in units of deaths per 1,000 individuals per year. There are a number of different types of mortality rates. Examples are as following: the fetal mortality rate, the ratio of fetal deaths to the sum of the births, that is, the live births plus the fetal deaths in that year; the infant mortality rate, the number of children dying under a year of age divided by the number of live births that year; the maternal mortality rate, the number of maternal deaths related to childbearing divided by the number of live births or by the number of live births plus fetal deaths in that year. The following are the principal rates used in measuring mortality: crude death rate, specific death rate, age-specific death rate, infant mortality rate, standardized death rates. Let us discuss about crude death rate. The crude death rate is the total number of deaths per year per 1,000 people. The crude death rate depends on the age and gender-specific mortality rates and the age and gender distribution of the population. The number of deaths per 1,000 people can be higher for developed nations than in less developed countries, despite life expectancy being higher in developed countries due to standards of health being better. The crude death rate is the simplest of all the indices of mortality and is defined as the number of deaths per k persons in the populations in the given region or community during a given period. Thus, in particular, the annual crude death rate denoted by M for any region or community. It is given that M is equal to annual deaths divided by annual mean population into K, where K is equal to 1,000 usually. The crude death rate for any period gives the rate at which the population is depleted through deaths over the course for the period. It includes following merits. It is simple to understand and calculate. It is perhaps the most widely used of any vital statistical rates. It is an index of mortality used in numerous demographic and public health problems. It is a probability rate giving the probability that a person belonging to a given population will die in the given period as the entire population of the region is exposed to the risk of mortality. Following are the demerits. The most crucial drawback of the crude death rate is that it completely ignores the age and sex distribution of the population. Experience shows that mortality is different in different segments of the population. The older generation are exposed to higher risk of mortality as compared to younger people. Moreover, mortality rate is also different for females irrespective of age groups than their male counterparts. Crude death rate is not suitable for comparing the mortality in two places or same place into periods unless The population of the places being compared have more or less the same age and sex distribution, or two periods are too distant since in a stable large community, age, sex, structure of the population shows very little change. It is to be noted that the crude death rate for males and females can be calculated separately. The crude death rate for males in a given region for a given period is calculated using the formula crude death rate for males is equal to male deaths divided by male population into 1000. Similarly, crude death rate for females is equal to female deaths divided by female population into 1000. Crude death rate usually lies between 8 and 30 per 1000. Female death rate is generally less than male death rate. Let us now discuss about specific death rates. In order to arrive at a more useful figure than the crude death rates, we must take into account the fact that the mortality pattern is different from different segments of the population. The various segments generally considered are age, sex, occupation, religion, community, social status, etc. For example, the people engaged in infant and child welfare work would be interested to know the mortality conditions in the age group below 1 year, 1 to 4 years, 5 to 9 years, etc. Those engaged in maternal health programs would like to know the number of deaths occurring amongst women in reproductive period, usually 15 to 49 years. Insurance authorities would be interested in the mortality pattern at different ages of the population. Investment banks might be interested in the mortality pattern of people belonging to a certain age group with a certain social standing or in a specific community. Death rate computed for a particular period specific to the section of the population is termed as specific death rate. Specific death rate for a given geographical region during a given period is calculated as specific death rate is equal to total number of deaths in the specified section of the population in the given period divided by the total population of the specified section of the given period into K, where K is equal to 1000. Usually, specific death rate is computed to specific age and sex. Age-specific death rates mathematically formulated as number of deaths amongst the person with age x or more but less than x plus n in a given region during a given period t. The total population of the age group x to x plus n is denoted by n of p of x. Then, the age-specific death rates for the age group x to x plus n is denoted by n of m of x and is calculated by number of deaths in the age group x to x plus n divided by total population of the age group x to x plus n into 1000. Taking n is equal to 1, we get the annual age-specific death rate as age-specific rate is equal to the deaths in the age group x to x plus n by population of the age group x to x plus n into 1000. To be more specific, the age-specific death rate for males is given by the formula age-specific death rate of males for the age group x to x plus n is equal to male deaths in the age group x to x plus n divided by total male population of the age group x to x plus n into 1000. Similarly, the age-specific death rate for females is given by the formula female age-specific death rate is equal to the number of female deaths in the age group x to x plus n divided by total female population in the age group X to X plus N into 1000. Both these formulas give the death rates specific to age and sex. Specific death rate reveal more facts about various segments of the population than the crude death rate. That is, if the death rate is high in a specific age group than old age, preventive measure can be taken depending on the situations. Thus, specific death rates are extremely helpful in planning and research. It includes following merits. The age-specific death rate has overcome the drawbacks of the crude death rate since they are computed by taking into consideration the age and sex composition of the population. It eliminates the variations in the death rates due to age-sex distribution of the population and provides a more appropriate measures of the relative mortality situations of the region. The age-specific death rate is one of the most important and widely applicable type of death rates. It also supplies one of the essential components required for computation of net reproduction rates and construction of life table. Following are the demerits. However, specific death rates are not of much use for overall comparison of mortality conditions prevailing in two regions A and B. It will not be possible to draw general conclusions regarding the overall mortality pattern in region A as compared to region B. In order to draw valid conclusions, the different age or sex-specific death rates must be combined to give a single figure which will reflect the true picture of mortality of the region. In addition to age and sex, distribution of the population, social, occupational and topographical factors come into operations, causing what is called differential mortality, and specific death rates completely ignores these factors. Let us discuss about the infant mortality rate. The infant mortality rate is defined as the chance of dying of a newly born infant within a year under a given mortality conditions. The infant mortality rate during the calendar year Z is calculated by considering the number of deaths among the children between the age group 0 to 1 divided by the total number of live births denoted in the same region within the same calendar year, where I of Z of n equal to the infant mortality rate during the calendar year Z. D of Z of n equal to number of deaths amongst the children between age group 0 to 1. B of Z of 0 equal to total number of live births within the same calendar year Z. Points to be noted are the infant mortality rate and age-specific death rate for age 0 have the same numerator. However, the denominator in the age-specific death rate at age 0 includes all the infants up to the age below 1 year. It includes following merits. The infant mortality rate is regarded as a more useful measure of infant mortality as compared to age-specific death rate for age 0. The other advantage of infant mortality rate is that it does not require the data of population census or estimates. The infant mortality rate can be obtained for any population, any region, provided that the data for infant deaths or live births for that period are available. The infant mortality rate is regarded as a very sensitive index of the health condition of a community or country and reflects any changes in its health standards, since the infant mortality rate is very responsive to any improvements made in the environment and medical conditions. Following are the demerits. The infant mortality rate has a serious drawback due to the under-registration of live births. As the definition of live births and stillbirths vary from country to country and for the same country from time to time, it is difficult to define infant mortality rate. Quite often, infants who are born alive but die immediately after birth are recorded as dead. This results in under-registration of live births and over-registration of infant deaths, leading to an overstatement of infant mortality rate than its actual value. Thus, by improving the birth registration system, we can lower the infant mortality rate without saving a single life. In the last 15 to 20 years, we have seen a steady decline in the infant mortality rates due to improvement in environmental and medical conditions. In addition to education of mothers, increasing the general awareness of child care, health and hygiene play an important role in reducing the IMR. Let us now discuss the standardized death rate. In the crude death rate and age-specific death rate, there are certain drawbacks in the formulation of the calculation since the age distributions of the populations between two regions are not identical. To remove this drawback, it was suggested to use the same set of weights for computing the weighted average of the age-related specific death rate. Such an adjusted death rate is known as standardized death rate. For example, the crude death rate in terms of age-specific death rates of two regions A and B are given. Age-specific male death rates for region A is calculated by age-specific death rates for region A divided by age-specific population rate for region A into 1000. That is, age-specific male death rates for region A is calculated by summation of age-specific male death rates for region A in the age group X to X plus N divided by summation of age-specific population rate for region A in the age group X to X plus N. Similarly, age-specific male death rates for region B is calculated by age-specific death rates for region B divided by age-specific population rate for region B into 1000. These expressions are the weighted arithmetic means of the age SDR, the weights being the corresponding population in the age groups. Standardization of death rates can be done in multiple ways, but we focus on the following two methods that are popular and lead to responsible, accurate results: direct method of standardization and indirect method of standardization. Let us discuss about direct method of standardization. In any standardization method, weighing of age-specific death rates is done using the corresponding population of the area to which they refer. However, the direct method consists of weighing the age-specific death rates by the population distribution of another region chosen as a standard. Thus, if Px to the power s is the number of persons in the age group X to X plus 1 in the standard population, then the standardized death rates for the region A and B are given respectively by standardized death rates for the regions A is equal to summation of age-specific male death rates for region A in the age group X to X plus N into number of persons in the age group X to X plus N divided by summation of number of persons in the age group X to X plus N, male death rates for region B in the age group X to X plus N into number of persons in the age group X to X plus N divided by summation of number of persons in the age group X to X plus N. If you notice, age-adjusted death rates for both the regions A and B are crude death rates that would be observed in the standard population if it were subject to the age-specific death rates of the region A and B. Note: the death rate may similarly be adjusted for other factors like sex, rate, etc., and interpreted accordingly. It includes following merits. Standardized death rates are easily understandable and easy to calculate. Age-adjusted death rates are comparable since they eliminate the differences caused by the different distributions of the age-specific population for regions A and B. Differences in these death rates gives a true picture of the differences in mortality in the two regions. Following are the demerits. The choice of standard population concept is a major drawback as it affects the magnitude of the resulting adjusted rates and might change the relative positions with respect to each other. However, in the calculations, if we take the standard population as the actual population for the larger region, of which the two said regions A and B used in the calculations are a subset, the above drawback can be removed. Let us now discuss about indirect standardization. In normal calculation of standardized death rates, we need to know the number of persons and age-specific death rate for different age of groups. However, in reality, though we might have the population count classified by age, total number of death and crude death rate, but the actual age-related specific death rate might not be known or available. In such cases, we use the indirect standardization method. The indirect standardization method, which consists of multiply the crude death rate of a region A by the adjustment factor C, where C is the measure of the relative mortality that the population is prone to in that region. Crude death rate is equal to summation of age-specific male death rates for region A in the age group X to X plus N into age-specific population rate for region A in the age group X to X plus N divided by summation of age-specific population rate for region A in the age group X to X plus N. Standardized death rates for the regions A is equal to summation of age-specific male death rates for region A in the age group X to X plus N into number of persons in the age group X to X plus N divided by summation of number of persons in the age group X to X plus N. Therefore, C is equal to summation of age-specific male death rates for region A in the age group X to X plus N into number of persons in the age group X to X plus N divided by summation of number of persons in the age group X to X plus N divided by summation of age-specific male death rates for region A in the age group X to X plus N into age-specific population rate for region A in the age group X to X plus N divided by summation of age-specific population rate for region A in the age group X to X plus N. Since mx to the power A data values are not known, we obtain an approximate value of C by replacing mx to the power A by mx to the power S. Thus, the standardized death rate using indirect standardization method can be arrived at as C cap is equal to summation of number of male death person in the age group X to X plus N into number of persons in the age group X to X plus N divided by summation of number of persons in the age group X to X plus N, which is whole divided by summation of number of male death person in the age group X to X plus N into age-specific population rate for region A in the age group X to X plus N divided by age-specific population rate for region A in the age group X to X plus N. The point to be noted are, we should not be comparing the direct and indirect method of standardization. The two methods are equivalent if the age-specific death rate for a given population is proportional to the specific death rate of the standard population. The indirect method is used as an approximation of the standard method only when data for the direct standardization is not available or unknown. Both direct and indirect methods of standardization have their own pitfalls and disadvantages. Both methods do not account properly for the mortality index obtained based on the age-sex composition of the standard population used. They also do not account for the gains in mortality reduction obtained at younger or older age. Let us take an example to understand the measurement of mortality. In this example, let us compute the crude and standardized death rates of the two populations A and B regarding A as standard population from the data. In the table, the first column represents the age group X. The second column represents the population of A for age X. The third column represents the deaths in population A at age X. The fourth column represents the population of B for age X. The fifth column represents the deaths in population B for age X. Solution is as follows. Let us calculate the crude death rate and the standard death rate for the given data for which we prepare the table. In the table, the first column represents the age group X, the second column represents the population of A for age X, the third column represents the death of population A at age X. In the fourth column, we will calculate the death rate per 1000, which is equal to 30, 20, 25, 35 and 50. The fifth column represents the population of B for age X. The sixth column represents the deaths in the population B for age X. The seventh column represents the death rate of population B per 1000, which is equal to 31, 22, 26, 35, 60. And in the last column, we will take the product of the death rate of the population B and the population A for age X. We will get 6,20,000, 2,64,000, 13 lakh, 10,50,000 and 6 lakh with a total of 38,34,000. In the next step, let us calculate the crude death rate and the standard death rate. The crude death rate is equal for population A is equal to summation x, death rate of population A divided by summation x, population of A into 1000 is equal to 3640 divided by 1,22,000 into 1000 is equal to 29.8. Similarly, for population B, we calculate the crude death rate by considering summation x of deaths of population B divided by summation x of population B into 1000 is equal to 3,349 divided by 1,22,000 into 1000 is equal to 27.4. Next, we will calculate the standard death rates for both the population. The standard death rates for population A is equal to crude death rate of population A, which is equal to 29.8. Since population A is taken as standard population, the standard death rates of population B is equal to summation of the product of the death rate of the population B and the population A for age X divided by summation of population A, which is equal to 38,34,000 divided by 1,22,000 is equal to 31.4. Look at this table for comparison. The crude death rate of population A is 29.8 and population B is 27.4, whereas The standard death rate of population A is 29.8 and population B is 31.4. Thus, we can conclude that the death rate in population B is greater than population A. Here's a summary of our learning in this session, where we have understood the measurement of mortality such as crude death rate, specific death rate, standardized death rate, infant mortality rate.